Good afternoon. So we had a really good turnout at our first LabVIEW Live event, so thank you everybody that came out and participated, asked questions, let us know projects you're working on. It was really good to see how many people came, so it's really encouraging. So thanks again, everybody. There were two really good questions / situations that came up in the stream, and I've already got some feedback on them, so I'm gonna walk through them. The first question, which is a relatively quick answer, is or the thing that happened was closing down these UI panels takes quite some time. And if we take a look at the base libraries array example where I was creating 500 panel instances, and we run this, it starts fast, it runs fast, but closing it down takes a while. I did try that separating the event signaling loop from the waiting for the VIs to close. That ends up, turns out that that's not what's slowing the shutdown down. It's because they're user interface events that are being used to send the shutdown signal. And there's only one UI thread in LabVIEW, so no matter how we parallelize sending those events, the LabVIEW execution engine, to my knowledge, will only still process one of those at a time. Now, some front panel controls do have options for locking or not the user interface panel while it's processing events. However, that's not something that's possible with user events. So unfortunately, there's not going to be a way to get lots of these user interface panels to close down. And anything that uses these event structures is going to suffer from that problem. But stay tuned to my channel because I do have some other ideas for more homogeneous arrays. So where with this library, it lets you create arrays that have any type of array panel derived class. But for other situations where you have an array of a single data type, there are better ways to do custom arrays for those, and I'll be working on some features to implement that later on, and then we'll only be having the number of panels open running at any one time as the number that are visible. So that will mean we'll have like 10 panels open, not 500. So that answers that question. And another one that came up was about code reuse within the inheritance chain of these panel classes. So for instance, in this temperature recipe editor, I've got this intermediate step panel class, and that does a lot of the data management for the UI panels. It knows that it needs a step, so it keeps track of the step. What else does it have? It's got some initialization stuff. It tracks the user events that are used to signal to the top level UI that it should do an update. It defines some of the panel properties for sizing. So it stops me from having to do those same things in all of these derived classes. But however, it's only in these like end of the inheritance chain classes where we can define this panel VI. And if we take a look again at how I am accomplishing this fake dynamic dispatch, I need to know the class name of the class that contains the panel VI to run. And the reason why I'm doing it this way is this obeys to the developer all of the mechanisms for dynamic dispatch in the development environment, except for being able to have intermediate VIs. What you could, this still would work. I could have a panel.vi in my step panel class. However, as long as I'm providing these leaf classes, my manager has no way to figure out that it should be looking in step panel to see if it has a panel VI class. Darren Nattinger did reply to a Twitter question already. There is a almost potentially amazing VI. Let me create a new VI here quick. There is a VI that works great in the development environment, but returns nothing when running as a compiled executable. So if we go into our VI lib, we're going to go down to utility and LV class. There is read class ancestry without loading. And you pass in a class path, which you can get very easily with this guy. And you can put whatever class type you need in here. And boom, we can see everything from top to bottom. And it does happily exclude the base object type, which is nice. So we can see we've got linear panel, which inherits from step panel, which inherits from array panel, which inherits from panel. This does not work in the runtime. It doesn't give an error or anything. It just gives nothing. There's no combination of property nodes or any other type of type inspection in the runtime engine that could accomplish this. And what we could do is we could check this and see if there's a panel.vi defined here. If not, we go to the next one. Is there one defined here? If not, go to the next one. Oh, this is our array panel class. We're going to stop looking there because we know we're not interested in displaying that if nothing exists higher up, which would be a problem because the environment should force you to have one in one of those derived classes anyway. But there's no way to accomplish this. There are some potential solutions. I could define a property on my array panel that gives back the reference to the panel VI you want to use as the VI as the panel interface. But that doesn't quite follow the dynamic dispatch rules that the framework already follows. So I don't like that as much. The other thing we could do is I could iterate over every VI in memory, find all the panel.VIs, and do two things. Check that they inherit from array panel. So you just have to do a typecast, see if it generates an error or not. And then of those ones that actually are array panel descendants, whenever you're trying to pass in like a linear panel, if a panel VI doesn't exist there, then you have to iterate over all of the you have to iterate over all of the classes in memory that had panel.vi as part of them, and see if you can typecast into that type from the panel class. But then you also have to test typecasting that into other types to make sure. You have to basically build the ancestry tree yourself, and it's not terrible. It won't actually take that long to do. That could be like one step that could get called every time you're initializing an array manager instance. That could even be done once and then stored in a functional global, so that just becomes part of application startup. However, if you're using this with a plugin architecture where plugins are dynamically loaded at runtime that have user interface panels in them, you'd then still need a mechanism for triggering that after you get your plugins loaded. So I do I would prefer to stay in this with the mechanism that's already in place. What could work better is the approach I did with my crafting calculator, where I don't have a different I don't have a different UI panel for each of my item types. I've got one item summary panel, which is this guy down here, that can get passed in, and this passes it in via a user interface, a user event. And then it updates its user interface the way it knows how, based on whether it has different crafting stations or not, and the other properties that are defined at the base layer. This follows a composition pattern instead of the inheritance pattern, and this is sometimes a much better way to organize code. A lot of times, especially with UI stuff, it doesn't need to be something different. It just needs to know how to. It needs to have something that it can operate on. Now that still won't solve if you want, different sets of parameters with the actual, like this is a numeric instead of a string, so I don't have to do any like type checking code every time somebody changes the value to make sure that they entered a number instead of garbage text. There's no way around having these different user interface components without either having a VI that contains all of the possible display elements you would need, and then hiding and showing and moving stuff around based on what you're showing, or you just have to copy a little bit of boilerplate code, because we were looking at these are the implementations for the 3 different step types, and they look very, very similar. And this is the boilerplate for how user interface panels are written with this library. We've got some event initialization and some handshaking to say, yes, we're registered for our events. You've got your event structure while loop, unregister for events, handshake that you're closed down. That's going to be the same in every panel, whether they look identical or look completely different. So just because it's LabVIEW, because of the way dynamic dispatch works within it, because of the way VI references and ownership of references and the lifetime of objects that the LabVIEW memory manager creates, there's too many weird situations that you have to account for if we tried setting this up so that step panel could define the user interface. But again, if step panel was defining the user interface, I would make these other panels not inherit from step panel, and then step panel would just know how to change its display based on which of the step types that it has assigned to it. Again, that's the composition pattern, and that's what I use over here in my crafting calculator. So yeah, if you have any more questions on this library or anything like that, let me know. Hit me up down in the comments. Twitter is another good place to get a hold of me. I am still working on trying to get this library saved to an older version of LabVIEW, so it is still only available in 2020. I did try backsaving. Instead of backsaving to 2012, I tried backsaving to 2014, and the backsave itself didn't complain, but it's still giving me errors when I try opening it up in LabVIEW 2018, which is the other environment I have on my work machine. So I'm going to keep poking at that to try and get this accessible to other versions of LabVIEW, but for now, you'll have to wait until 2020 gets released or be in the 2020 beta to start playing around with this. So I hope to see you all again, and thanks for stopping in.